In this video we'll synthesize propiophenone using a Friedel-Crafts reaction between benzene and propionyl chloride. Start by setting up a 250 ml flask with stirring. Next, weigh out 22 grams of anhydrous aluminum chloride. Be very careful to protect this from atmospheric moisture. Measure out 37 ml of benzene. Note you'll need another 25 ml later on as well. It is very important that the benzene is completely dry. Transfer the aluminum chloride and the benzene into the 250 ml flask. We saw a slight yellow color at this point, but this may just be due to impurities. Place the flask in a cold water bath with a temperature of 10 degrees C and get the contents stirring. This may be a little difficult due to the amount of solid, but we managed to find a setting which worked. Set the flask up with an addition funnel and a way to vent to the atmosphere so that pressure can't build up. You will also need a way to protect the reaction from atmospheric moisture. We built a DIY drying tube to fit on the top of the apparatus. Now measure out a further 25 ml of benzene, and then measure out 15 ml of propionyl chloride into the same measuring cylinder. You can check out our other video for instructions on making this. Use ventilation at this point because propionyl chloride is toxic, and also gives off lots of fumes of HCl gas, which is corrosive. Place this mixture into the addition funnel and then set up your drying tube. Now add some more ice to the water bath and make sure that the temperature of the water bath and the flask is at 10 degrees C. Start adding the benzene and propionyl chloride mixture very slowly, 1 drop every 3 seconds or so. It is very important that you watch the stirring in the flask and make sure that this doesn't freeze up. Stirring is essential for a good yield. At this rate of addition it should take around 1.5 hours to completely add the mixture to the flask. Add more ice to keep the temperature at 10 degrees during addition. On complete addition, heat to 40 degrees C on the water bath and keep stirring for a further 2 hours. At the end of this period the reaction mixture will be a dark color like this. Then allow the mixture to cool, and prepare a large beaker containing 100 grams of ice and 10 ml of concentrated hydrochloric acid. Pour the contents of the reaction flask onto the ice and acid mixture. You'll see the dark color disappearing as it touches the ice. This is an intermediate compound created by the reaction hydrolyzing into our product. The mixture will bubble slightly and become warm. Swirl the beaker and you'll see the hydrolysis complete. Stir the mixture well and then allow to settle. You should have a bright yellow organic layer like this. Pour the mixture into a separating funnel and then allow to settle again. Drain off the bottom aqueous layer and discard this. Get as much water out as you can, and then transfer the top yellow organic layer to a large 500 ml flask. What we need to do now is steam distill the mixture. You can do this by injecting steam into the flask, but we found that it also works if you add water and distill directly. So add 150 ml of water to the flask. This will form a bottom layer again. Now prepare 10 ml of a saturated sodium carbonate solution, and add this to the flask. This is to ensure that all residual acid in the mixture is neutralized and doesn't come over with the steam. Now set up for simple distillation. No need to use a thermometer. A milky benzene and water azeotrope is first to distill. from the flask and collect. At this point the yellow color remains in the boiling flask, but keep going and soon you'll see that the benzene has distilled over completely, and water is now distilling over along with an oily pale yellow product. After a few hours the product collected looks like this, and at this point we checked the aroma of the distillate and it had no sweet smell, so we stopped here. At the end of the distillation, the boiling flask also contained the yellow residue on the sides. Here's the product of the distillation so you can see the volumes, a yellow organic layer and a clear aqueous layer. We transferred this into a separating funnel, and then carefully removed the bottom aqueous layer. We then transferred the yellow organic layer into a beaker, and added about half a teaspoon of anhydrous calcium chloride. To remove any water, we left this for half an hour to get as much water out as possible. Transfer into a 250 ml flask, and set up for distillation again, this time using a thermometer to record the temperature of the fractions coming off. First to come off is benzene, as a very slightly milky liquid due to a small amount of water still present. This came off at exactly 80 degrees. We then noticed a small amount of another fraction which came off at about 110 degrees C. Then the temperature rises rapidly, and propiophenone starts to distill off at just over 200 degrees C. This is a very pale yellow liquid. We used some foil to insulate the apparatus to help the distillation. At the end, just a small amount of orange-colored liquid was present in the boiling flask. We collected around 40 ml of benzene, shown here, which we were able to use in another reaction. And here's our product, 13.97 grams of propiophenone as a slightly oily, very pale yellow liquid. This corresponds to a 63% yield calculated based on the starting propionyl chloride. This is less than the literature yield of 84%, but better than some reports we read of a 50% yield, and could probably be improved if the reaction was scaled up. Propiophenone has an unusual sweet, aromatic and slightly spicy aroma, which takes a while to wash off anything it touches.